In 9.3, we're going to add and subtract square roots. And just like with adding and subtracting like terms, we can add and subtract like radicals. We just have to have the same radicand, which is the number inside the square root. So on these, just pretend that the radical part is the variable. So if you remember, when we had x plus x, that's the same as saying 1x plus 1x is 2x. If we had x plus 3x, that's the same as saying 1x plus 3x equals 4x. If we had 3x squared minus 2x squared, that's saying 3 minus 2 is 1x squared. So we just put an x squared. We're going to do the same thing with radicals. So say we have 6 square root 11 plus 9 square root 11. Since we have the same number under the square root, which is the radicand, we can just add the numbers that are on the outside. So 6 plus 9 equals 15 square root of 11. If we have square root of 7 minus 3 square root of 7, that's 1 square root of 7 minus 3 square root of 7s. So that's going to be negative 2 times square root of 7. Let's say that we have square root of 2 plus square root of 2 minus square root of 15. So this one has a different number inside there, so we can't combine it, but we can combine the 1 square root of 2 plus 1 square root of 2 equals 2 square root of 2 minus square root of 15. Now if we have 3 square root of 3 minus 3 square root of 2, we can't do anything here. Even this one might confuse you because the numbers on the outside are the same, but it has to be the numbers under the square root sign that are the same in order for us to combine them. Okay, so that's when they already start out the same. Let's say though that we have square root of 27 plus square root of 75. Now here, 27 and 75 are two numbers that we saw in the previous section that a perfect square will go into them. So we're going to change these to be square root of 9 times 3 plus square root of 25 times 3. So we can take the square root of 9, which is 3, and we're left with square root of 3, plus square root of 25, which is 5, and we're left with square root of 3. And now we have the same number here. So we can add the 3 plus the 5 and get 8 square root of 3. Let's say that we have 3 square root of 20 minus 7 square root of 45. So again, a 4 will go into 20 and it'll go 5 times, and a 9 will go into 45 and it will also go 5 times. So we can say 3 times square root of 4 times 5 minus 7 times square root of 9 times 5. We can take the square root of 4, so we're going to have 3 times 2 square root of 5 minus 7 times square root of 9 is 3 square root of 5. Now we need to multiply the 3 times 2, which is 6 square root of 5. We have minus 7 times 3, which is 21 square root of 5. And now we can subtract 6 minus 21 is negative 15 square root of 5. All right, so next, let's say that we have something bigger or with more terms. Say we have square root of 36 minus square root of 48 minus 4 square root of 3 minus square root of 9. Okay, so let's look at this. The square root of 36 we can do. Square root of 9 we can do. 3, that's a small number, so we can't do anything with that. And 48 also isn't a perfect square. But because this section is telling us that they want us to combine and add and subtract radicals, let's see if 3 will go into 48 so that we can combine them. And 3 will go into 48. It'll go 16 times, which is a perfect square. So what we're going to have now is 36 minus square root of 16 times square root of 3 minus 4 square root of 3 minus square root of 9. So now I'm going to take the square root of what I can. Square root of 36 is 6 minus square root of 16 is 4 square root of 3 minus 4 square root of 3, and then square root of 9 is 3, so minus 3. Now I can combine like terms. I have 6 minus 3, which is 3, and I have minus 4 square root of 3 minus 4 square root of 3, which becomes minus 8 square root of 3. And that's as far as I go on that one. Okay, so let's say that I have square root of 9x to the 4 minus square root of 36x to the 3 plus square root of x to the 3. Okay, so I can do this in two ways. I can either just take the square root of 6, or I can just take the square root of everything that I can, and that's the step I'm going to do. So the square root of 9 is 3, and square root of x to the 4 is x squared. And we have minus, we can take the square root of 36, which is 6, and I'm going to be left with x squared, square root of x squared times x, and then plus square root of x squared times x. Because remember, I'm subtracting 1 from the 3, and I'm also going to have the x. So now I'm going to take the square root of the x squareds. So I'm going to have 3x squared minus 6x square root of x plus x square root of x. So now that I have like terms on the outside of like radicals, I can combine that and get 3x squared minus, we have minus 6 plus 1, so minus 5x square root of x. Now on this one, I could have also just said, I'm just going to look at this part of it here. I'm going to take the negative 6 square root of x to the 3 plus square root of x to the 3. Because we already have the like radicals. I took the square root of the 36. I could say negative 5 square root of x to the 3, and then take the square root of that part. So negative 5 square root of x squared times x, or negative 5x square root of x. It doesn't really matter what order you do those in, as long as you go completely and go as far as you can.